This video will demonstrate a problem where you are seeing the difference between using the standard normal distribution to answer a question about one randomly selected individual thing, and then the second part will show answering a question about the sample mean. So the average sodium content in a brand of frozen dinners is 550 milligrams, has a standard deviation of 30 milligrams, and the sodium variable is normally distributed. If you randomly select a single dinner, then answer the question, find the probability that the sodium content is more than 570 milligrams. So we're trying to figure out if in fact the sodium content is normally distributed with a mean of 550 and a standard deviation of 30. What's the chance of us picking a randomly selected dinner and having the sodium content more than 570? So we're going to try to use the standard normal to answer this question. So we'll have to standardize it. We have to make a z out of it. And we use the formula that we've been using. You find your z by taking 570 minus the mean, 550, and then dividing it by the standard deviation. I'm going to use my calculator. So 570 minus 550, and then I'm going to divide it by 30. The z is 0.6666, so I'm going to call it 0.67. So now we're going to go to our standard normal chart, and we're going to look up 0.67. Now remember, your chart's going to give you the area on the left of this, and we really want it on the right. But first we'll find the area from the left. So 0.67 is right here. It's 7486. And then to get the area to the right of this, we subtract from 1. So this would be 1 minus 7486. Looks like 0.2514. So right about a 25% chance that you would get a package, an individual package that has more than 570 milligrams of sodium in it when the average is 550 and the standard deviation is 30. Then the next question is, if you take a sample of 10 dinners randomly, want to find the probability that the mean of the sample will be more than 570. So now we're not talking about an individual item, we're talking about the mean of the sample will be more than 570. When we use the central limit theorem to standardize, the numerator looks the same as it did before in the formula, but the denominator, instead of just the standard deviation, it's the standard deviation divided by the square root of the sample size. This denominator is called the standard error. It's the standard deviation of the sample means, and it needs to be calculated in there to get the z. So let's put it in our calculator. We're going to do 570 minus 550 in the numerator, just like I did before. But the denominator is going to have the standard error in it instead of just the standard deviation. And now the z I'm getting is 2.108. I'm going to round it to 2.11. So now the question we're answering is this. So when we go to our table, we're looking for over on this direction, but again, your table will give you to the left. So let's look up a z of 2.11. It's right here, 9826, right there, 9826. And then we'll subtract it from 1. So only about a 1% chance of this. So pretty good chance that we could pick one individual dinner and get more than 570 milligrams, but picking 10 of them and having the average of that be more than 570 when the mean is 550 isn't very likely.